All right, so in each of these ones, they look a little bit strange. There's a bit of extra bit. So we'll try and make something be f of x and look for f dash of x. For example, if I look at A, if I make f of x equal to 1 on x, we get, if we differentiate that, so that's the same as x to the -1, we get negative x to the -2, which is the same as -1 on x squared. So if I rewrote that integral, -1 on x squared is the f dash of x part. So it's like I have f dash of x, and then I have e to the f of x dx. So it's as if I had that. Now, if you look at your reference sheet, you'll see you get e to the f of x plus c. So, and f of x in this case is 1 on x. So e to the f of x plus c is your solution for A. Now, another way I like to do it, I'll only do this once. This is my preferred method, but the book kind of uses this method, so I'll do that. I like to say something like let u equal the 1 on x. So that means du dx, but I'm going to put the x on the other side. So if I differentiate u with respect to x, I do get that just like that. So if I have a look at the integral, you can see that this whole part here now equals du. So -1 on x squared dx is equal to du. So I can rewrite it as the integral of e to the 1 on x, and 1 on x is u, so it's e to the u du. And when I integrate an exponential, just an easy exponential e to the u, I get e to the u plus c, and then I could just put the x back in, the u back in, and u is 1 on x. So I actually like to do it that way. I may show you that way again. Let's see how we go for time. Okay, so now if I look at the second one, we have to decide what we're going to let be f of x. And in this one, if you think about it, for b, the f, you want sec squared of f of x. I know how to integrate sec squared. I get tan. When you differentiate tan, you get sec squared. So the weird thing is it's not just sec squared x, it's x squared. So I'm going to make, that one is, oh sorry, I'm looking at C. I'm going to make that one x squared. And so f dash of x is going to be 2x. And you can see that we have an x, we don't have a 2x. So what we could do is just make it, we could make it a 2x, sec squared x squared dx. And we could put a half out the front, and that covers it. So you can see that in the same way I would when I did the u's, the 2x dx would be the du. But here we have a half, we have f dash of x happening, then we've got sec squared of f of x dx, and we know from the reference sheet that this would be tan of f of x plus c, so e should be plus c, which is tan of, what was f of x? X squared plus c. So there's our answer. I'll just do it once more using u's. So sorry, this is question C. So if I made u equal x squared, then du dx is 2x, or du equals 2x dx. I can see that if I rewrite this equation as a half, I put my 2x there, sec squared x squared dx. So this whole bit here, the 2x dx is my du, and sec squared, so x squared becomes u. So that's nice and easy because sec squared u integrates to tan u. Then we've of course got plus c, and then I'll change the u back into x squared. So we get that easy. All right. Okay. So let me go back to question B. Sorry about that. So in question B, same thing. I'm looking for something for f of x where the derivative is there as well. If I have a look at this one, if I just take the bottom and check, so sometimes it doesn't work, but hopefully this works. So derivative 1 is 0, sine 3x becomes 3 cos 3x. So the cos 3x is there but not the 3, so we could put a third out the front, and then we've got 3 cos 3x on 1 plus sine 3x dx. Now, if you can see, that's really the same as f dash of x on top and f of x on the bottom, which from your reference sheet is log of f of x. And here f of x is 1 plus sine 3x plus c, of course. So it's log. If I did it using u's, which I like to do, so I would have let u equal 1 plus sine 3x. So du is differentiate 1, you don't get anything. Sine 3x, we get 3 cos 3x dx. Now, that whole thing, that 3 cos, if I put a third out the front, then I have 3 cos 3x dx there. So the integral becomes a third integral of this whole bit is du. So du, I've got u. So in other words, I shouldn't have written it like that. I should have written, so 1 on u is u to the negative 1 with respect to, I'm integrating with respect to u. Now we know I could have written 1 on u. 1 on u is just log u when we integrate. So I have log u plus c. Don't forget the third. And then I just change the u back to x's. So it's 1 plus sine 3x plus c. So I prefer doing it that way, but it's totally up to you which way you do it. Okay, if I look at d now, please pause when you need to. All right, looking at d, again, my f of x here. So it's just about choosing what your f of x is. Actually, for this one, I'll do the way we did it before, where we said we can't integrate with a base of 5. We need a base of e. So e log cancel each other, and then I'll do 5 to the 2x with respect to x. Now, this is the same as if I just use the log laws. So it's log 5 2 squared and all to the power of x. So I'll put x down the front. So it's all of that there. Okay, just using log laws. Now, we know that e to the f of x, we've done this one before, we need the division by f dash of x. So f dash of x here would be log 5 squared. So I'm dividing by log 5 squared or log 25, up to you how you write it. And I've just got the same, I should have the exact same thing on top. So the e log 5 to the 2x, which is the same as just 5 to the 2x. So if you're okay with it, you can just put it down, no problem. All right, so either you're going to have written it that way, you could also have written it as 2 log 5, that's exactly the same, plus c, either way. Okay, so that one we can just do like that. All right, let's have a look at e. So for e, I'll make my f of x equal, oops, you get my gist, x plus 10x, because that's the bottom, and we'll just check if that works. So f dash of x, I get 1 plus 10x goes to sec squared x. I get 1 plus sec squared x, which is the top. So it looks like we've got the integral very nicely of f dash of x on f of x, which we know is a log, so that's pretty easy. If I was doing it with u's, I would let u equal x plus 10x. I would du is 1 plus sec squared x dx. So all of that dx. So all of that top becomes du. So I'm integrating 1 on u du, which we know is log of u plus c. So that gives me log of, what's u? X plus 10x plus c. So either way, we should get that. All right, and f, let's have a look at f. So I might just do it with u's here. So think about what you're trying to get. The top is e to the x. Now, if I differentiate e to the 2x, I don't get, I'll still have an e to the 2x inside. So with the exponentials, it's always a little bit weird. But when I differentiate, I get e to the x dx, just like that. So you can see that whole top bit will become du. So that integral there will become du on the square root of 1 minus, now this is e to the x squared, makes e to the 2x. So this is 1 minus u squared in a square root. Now that one there is, again, on your reference sheet, it would be inverse sine of u plus c. So our answer is going to be inverse sine of e to the x plus c. If I was looking at it using f of x's, let's have a look here. So I would have made f of x equal to e to the x, and f dash of x would also be e to the x. So my integral would become f dash of x on the square root of 1 minus, and this would have been f of x all squared. So again, there we go. So again, we would have got, oh, that's inverse sine of our f of x from our formula booklet. And our f of x is e to the x. So we would have also gotten that. All right, I hope that's helpful. Let me know if you have any questions.